Welcome back to another episode of the Future Cities podcast. I'm your host for the month, Stephen Elser. I hope that you're doing well and staying safe as best you can during this pandemic. I, like many of you, have been stuck inside my home for a few weeks and will likely be here for a while longer. During that time, I've been looking at my window a lot, wishing that I could go out and do all the things that so many of us took for granted before social distancing became the new normal. And outside my window is, among other things, a tree. And staring at it as much as I have over the past couple of weeks has made me think a bit more explicitly about the benefits that tree gives to me. First off, it's a pretty tree. It's nice to look at, full of leaves and small green fruit. It also serves as habitat for a variety of birds, which I sometimes observe eating those small green fruits. It blocks not only the view of a usually busy road, but also some of the noise from it, which is helpful when I'm trying to sleep or when I'm recording a podcast. And when it's hot out, its shade keeps our apartment a bit cooler. Yes, trees provide all sorts of benefits, and in today's episode, we'll talk a bit more about some of the benefits that trees provide to us and what we can do to help keep trees healthy in our cities. Without further ado, let's get to the conversation. Our guest is Jenna Rindy.
So my name is Jenna Rindy. I am a first-year PhD student at Boston University, and I am currently studying urban forestry. Basically, I like to sum up my path of how I got here with a quote from a professor in Boston University's Earth and Environment Department, and his name is Dr. Nathan Phillips. He said, "Have a direction, but not necessarily a plan," and that's basically been my entire life so far. I've never necessarily had a plan to get where I am now, but I did know that I wanted to be somewhere like here at some point. So I grew up about an hour away from Pittsburgh, Pennsylvania. So, shout out to the Yinzers there. My dad was an environmental scientist. So he worked as a consultant, and one of the things he did was test homes for mold, which is kind of how I started to understand science. I'm pretty sure I could say different names of mold like Stachybotrys by the age of like 6. So it was really interesting. It was really interesting to me because I had and still now have asthma. So I could understand the science behind like mold and how it causes asthma and allergies and things like that. But interestingly, when I started my undergrad degree at Slippery Rock University in Pennsylvania, which is, yes, a real school. People ask me if that name is real. It is. um, I actually started as a communication major and a journalism major. And I started in that field because I really wanted to be a science writer. But after a while, my dad's scientific background kind of made me realize that I wanted to communicate science effectively. And if I wanted to do that, I should immerse myself in the sciences first, understand their concepts, and then practice communication. So I ended up switching into our environmental science major. So I took a bunch of field-based and lab-based courses in biology, geology, ecology, and then air and water chemistry, which was really interesting. And then in my last semester there at Slippery Rock, one of my professors sent me a call for a master's student from a PI at the University of North Texas in Denton. Denton is about an hour north of Dallas. So a few months later, I packed up and moved to Texas, and then I ended up working alongside my PI there, Dr. Alexandra Pinette Gonzalez, on her NSF-funded study to look at how trees remove black carbon from the atmosphere. And then after my master's, I worked for a while as an adjunct at Texas Women's University. And then I got a call to work as a PhD student in Pam Templer's lab at Boston University. So now I'm here. And you can see that although not all of the opportunities I've taken in my life were planned, I knew where I wanted to go. I knew I wanted to research and communicate science. So I just made it a goal to get here. And I think that I am pretty lucky to be where I am now.
Yeah, well, it seems like you're doing pretty well for yourself.
It feels like it.
Your comment about how you could name a bunch of different mold species from a young age resonated with me because so my parents are both scientists as well. My dad is a limnologist, so he studies inland bodies of water and what lives in them. And one of his study species is a type of zooplankton, Daphnia. And so when I was a wee young child, first, second grade, I knew of Daphnia, these tiny little water fleas that exist in lakes and ponds, and I would see them in my dad's lab. And on some like arts and crafts project in second grade, we were told to make like a your favorite animal out of construction paper, and I chose to make a Daphnia. Uh, and
Yes, we scientists are a little strange.
yeah, a little strange for sure. I'm sure my second grade teacher thought I was probably just making up this animal.
Yes, I definitely relate to that.
Yeah, anyway, so that just sort of resonated with me. Thought that was fun. Um, yeah, so now you've started. Now your focus is on trees, and I wonder how studying trees or how your experience studying trees differs from scientists studying different sorts of systems, because trees are ubiquitous. They're everywhere. Everybody knows what a tree is. Everyone has an idea of like in their head, oh, they can imagine a tree really easily. They see them every day in their lives. So do you think that that has had any effect on the way that you are able to communicate your science? Do you think it's made it easier for you to communicate the importance of your work? Have you encountered misconceptions about trees?
I think I found that it's easy for people to understand how trees remove pollution from the air, which is what I study, because people are so familiar with the trees, either in their own yards or in the parks they walk in, so they feel a sort of connection to them. So I've definitely encountered people who are really excited about my work, but they also tend to be the same type of people, the same people who have misconceptions about trees and my work, especially when I present to constituents in the city, people who are really interested in participating but not sure how. I'll share my research with them, and they're really excited, and they want to plant more trees, which is great. Unfortunately, it's not all about planting the trees. It's also about maintaining them so that they can grow to their full pollution removal potential, or their full potential to provide ecosystem services for us.
Yeah, right. Sort of people have this sort of short-term energy and vision of what to do with trees, but yeah, you got to keep up with them in order to make sure they're actually giving us the benefits that we want.
Right, exactly. Yeah, it's all about maintenance, not just planting all the trees.
Yeah, I know that's a big issue here in Phoenix. I think something like the median street tree age for city of Phoenix is something like maybe 7 or 8 years, something like very low. Trees die out here on the street, and it's
Yep.
tough to maintain that urban forest. But it's so important
Yes.
to do that.
Definitely. Yep, we have that issue here as well.
So yeah, as you mentioned, you did your master's degree at the University of North Texas, and you're currently working on your PhD at Boston University. And in both
Yes.
instances, you have had your focus on urban trees. But obviously, North Texas is hugely different from Boston. So could you compare your experiences studying trees in these two very different locations?
So, of course, there's the main difference, which is that the types of trees that grow in Texas don't grow in Boston, right? So, although I studied oak trees in Texas, we don't even have the same oak species here in Boston due to the differences in soil type, temperature, climate. Um, but the species are definitely not where the differences end, right? The differences between Denton, which is North Texas, definitely a warmer city, and Boston, as cities are apparent when it comes to city planning too. Boston is obviously a much larger city, a larger population than Denton. So Boston planners need to take that into account, right, when they're planting trees to mitigate emissions. Because I study how trees mitigate different types of pollutants, Denton is actually doing an amazing job as a smaller city. They're taking huge steps to become carbon neutral. They're currently voting on decreasing their carbon emissions by 80% by 2050. And included in their plan, they are talking about increasing tree canopy coverage. They're talking about citywide studies to understand Denton's urban forest, how much pollution it actually removes from the atmosphere. And they're also making sure to not only preserve species diversity, but especially the species that help mitigate pollution. So Denton is really leading the way in sustainability efforts on the urban forestry level. Boston is also doing an amazing job. Interestingly, Boston and Denton both the percent land area covered by tree canopy is about the same in both cities, even though Denton's a lot smaller.
Oh, wow.
Both cities are about 30% canopy covered. And Boston recently released their 2019 climate action plan, and within their climate action plan, they also have the goal to reduce their emissions 80% by 2050, just like Denton is voting on. And part of Boston's plan is to replace dead street trees that were killed by gas leaks or lack of attention. So we have a really big gas leak issue in Boston, and that gas will actually escape and kill off the street trees. So we're trying to replace those trees and provide them the attention that they deserve. So even though there are different population sizes, different land mass sizes, different species of trees in these cities, it's really interesting that in both the cities, regardless of all those differences, we have a huge participation when it comes to community support for trees. So there's a lot of initiatives in both cities. And I've definitely had no issues with people thinking that the research we do isn't important. I really believe that goes back to the common appreciation that we all have for trees.
Yeah, that's really interesting to see how two very distinct cities share so many similarities in terms of their urban forest. You mentioned that 30% canopy cover, or being about 30% canopy cover in both cities, and that's actually what the city of Phoenix is aiming to achieve as well. So in 2010, the city published a tree and shade master plan to help achieve 30% canopy cover by, or actually, excuse me, 25% canopy cover by 2030. And this was 2010. I think around that time, there's about 12% canopy cover. So it's like a huge jump in that 20-year span. But yeah, it seems like a lot of cities are trying to go to that, approaching that 30% or so.
Yeah, and it's definitely more difficult in climates like Arizona, right? So
Yeah, right.
you don't necessarily have larger trees there to plant, because the species of trees that tend to inhabit that area are smaller and able to conserve their water better. So reaching that 30% canopy cover is going to be harder there than it will be for a place like Boston.
Yeah, exactly. And then that sort of begs the question: um, is this a realistic goal for us to even set for the city of Phoenix to get to that goal? And given how difficult it is to maintain that infrastructure, but then also just in terms of the water that might be necessary if you're not planting native tree species, there's just all sorts of sort of trade-offs you have to think about, when it comes to these trees.
Right. Yes. Every tree is going to behave differently, and there's a lot of city planning that goes into that for sure.
Great. So let's talk a little bit more about some of your master's work. So you shared with me a paper that you published in 2019 in the Environmental Science and Technology Journal called Urban Trees Are Sinks for Soot, Elemental Carbon Accumulation by Two Widespread Oak Species. So I do a little bit of tree ecosystem service related research myself. So I thought this was a great read and had a lot of good tidbits to take away. But let's break things down a little bit more for people listening at home. So what is soot or elemental carbon, and why should folks in cities care about it?
Yeah. So elemental carbon, it's also called black carbon. Those are just words we use for soot. We actually call it different things based on how it's measured, but in general, it all refers to the same particle. We can just call it soot. Um, Basically, it's a particle, or more specifically, a hunk of different different particles, but all of the same type that come from human activities like car and factory emissions. Soot is very bad for both the climate and human health. On the climate side, it absorbs a whole lot of heat, which then heats the atmosphere around it. So we actually consider it to be one of the biggest pollutant contributors to climate change, along with carbon dioxide. On the human health side, the subparticles are really, really small. So when people breathe them in, they actually get embedded into the lungs and cause breathing issues like asthma. And they can even get embedded into the bloodstream and cause heart health issues. So for those reasons, soot is a really big deal, but especially in urban areas, because urban areas have a lot of sources of soot emissions, like cars, and a lot of people. So all of these people are susceptible, or all of these people are exposed to soot. And so that combination of a lot of sources and a lot of people isn't good for human health or climate issues. So that is why we chose to look at how urban trees can take up soot from the atmosphere.
Yeah, right. And that is one of the many benefits that people tend to report about trees, is that they can clean the air, improve air quality, and thus improve human health. So, and this paper and your findings are another example of that benefit. So, could you tell us a little bit more specifically what your objective? Could you tell us a little bit more about what your objectives were and what you found?
Some research previously has looked at how much soot is in the air, but no one really looks at how to take it out of the air. So we used trees as our mitigation method for that. We chose 2 different oak species that are very widespread across the southeastern US, so that our research could be replicated and could actually have tangible implications for planting and maintenance. Um, we looked at a post oak tree, which is a deciduous tree, and we looked at a live oak tree. We sampled them across the city of Denton, and we found that post oaks are actually able to capture almost twice as much soot from the atmosphere than live oaks. They were sampled over the same time period. The trees were the leaf area index of the trees were all measured, so we actually accounted for the size of the canopies, and we found that along with post oaks removing twice as much soot from the atmosphere as live oaks, both the species remove soot from the atmosphere when we need them to do it the most. So it's not just the amount, but it's also seasonal. The concentration of soot in the atmosphere are highest in the Dallas area in fall and winter. And we found that was when the EC, or the soot, deposited most on all of our leaves. So it's really important to note that although these trees are different, in they're a deciduous and an evergreen species, they're both very important because they remove soot when we need them to.
Yeah, that is really important. The timing of that ecosystem service is so essential, because if it's not really removing the soot from the air at the correct times, it's not really providing that much of a service.
Right, exactly. Yeah, it's all about timing and quantity.
Yeah, so it sounds like probably one of the main reasons why there's this big difference in between the two species is that one is deciduous and one is not. Do you think there are any other reasons why you might have observed this difference?
Yes, definitely. So your point, you mentioned their phenological difference, which means the difference between the species and how they act over time. So post oaks lose their leaves in the fall, just like any typical deciduous species. Live oaks are considered evergreen. Basically, that means that they keep their leaves throughout the year. Live oaks actually do lose some of their leaves in January, February-ish, but not all of their leaves, only some of them. So in terms of phenology or time, you would think that live oaks should actually be able to accumulate more soot on their leaves because they keep their leaves year round. But that didn't turn out to be the case. So then we turned our focus on physiology. So physiology basically means that the two species have different canopy and leaf structures and different defense mechanisms on them. So one of the factors here was likely airflow and the different shapes of the canopies. So airflows within the post oak canopy likely contributed to a higher particle deposition onto the leaves, opposed to the shape of the live oak trees, which have a really closed canopy structure. So it's really hard for the wind and the particles to get into that canopy. Most likely, more importantly, though, the leaves are completely different. Post oak leaves are large and have lobes on them, while live oak leaves are small and elliptic shaped. So they're kind of aerodynamic shaped if you think about it. Post oak have defense mechanisms on their leaves called trichomes. Trichomes are hair-like features on the tops and bottoms of the leaves, and usually what they do is defend the leaf, but trichomes actually capture a whole lot of particles too. So interestingly, what we found was that live oak leaves only have trichomes on the bottoms of their leaves, whereas post oaks had them on the tops and the bottoms, and they had more. So there are definitely a bunch of physiological factors that led to post oaks retaining more soot on their leaves than live oaks, most likely at the leaf scale though.
I wonder whether you are aware of other sorts of trade-offs between these two species. So is the post oak good at doing at providing other ecosystem services as well, or does the live oak is the live oak better in some ways?
Yeah, so really the main benefit of the post oak tree is that it is native to the North Texan area. So we find it very important to preserve post oak trees because they're native to the area, and they also are not able to be transplanted. So it is very difficult to grow a post oak in a nursery and then plant it in someone's yard. And instead, we're planting live oak trees, um, which is unfortunate based on the amount of soot live oaks retain versus post oaks. So they do have differences, and one is easier to grow than the other. And it's really important to have both, but to make sure that we are also preserving the post oaks at the same time as planting live oaks.
So now let's move on. So you're in your PhD now. You're in your first year, and you're continuing to study trees, but now you're studying urban forest fragmentation and how that fragmentation affects how various nutrients and particles deposit due to that fragmentation. So first off, what is forest fragmentation and why study it?
Right. So fragmentation in general is just the breaking up of ecosystems due to anthropogenic activities. When I say anthropogenic activities, I just mean things humans do. Basically, what that means is humans build things like roads, agriculture fields, utility corridors, and in the process of them building, they cut right through natural habitat. Any habitat can be fragmented by human activities, but a common habitat that is fragmented is forest. So picture one large forest, and then we cut right down the middle of that forest so a road can go through it, which fragments the forest into two pieces. Studying this fragmentation is important because the edges of forests that are up against that, what we call the edge or the fragmentation edge, are more exposed to emissions than trees that are in the interior of the forest. So thinking of it like this, if a car drives down the road that was just cut through a forest, and a tree that was previously in the middle of the forest is suddenly exposed to a whole bunch of emissions coming from that car or multiple cars driving down the road, suddenly that tree and all of the trees along that edge are going to act differently. So studying forest fragmentation gives us a better insight into how humans affect our natural environments. And although fragmentation happens in rural areas, it happens even more so in urban areas because of development.
Following up, you do also study how that fragmentation affects the deposition of nutrients and particles. So, what nutrients and particles are you studying? Are you continuing to look at soot, or have you moved on to something else?
Yes. So eventually, I plan to look at particulate matter in general, which is soot is a small component of particulate matter. I do plan to continue my study on particulate matter, um, how urban trees remove particulate matter from the atmosphere, and how that particulate matter actually hurts trees. Right now, I am looking at nitrogen as an anthropogenic pollutant. In small amounts, nitrogen is great for trees because it acts as a fertilizer to help them grow. But urban areas are often saturated with nitrogen. Nitrogen is deposited onto tree canopies from human activities, and then that nitrogen is either taken up by the canopies or washed to the ground in the soil. We study how much of that nitrogen is actually being taken up and used by those trees. And then when the trees can't take up any more nitrogen, they call it saturation. They can't take up any more. It leaves the forested systems in runoff during rain, which eventually can pollute our waterways. So we look at how trees respond to nitrogen in all forms, including nitrogen oxides, gaseous forms that come out of our car engines from burning fossil fuels. So eventually, after that, I will look at particulate matter, how much particulate matter urban trees take up, how that particulate matter hurts trees, and then how living near to forests can help human health. So, particulate matter, very similar to soot, can do multiple things to damage tree leaves, which eventually can cause the tree to decrease its productivity. So, although we know trees can help us breathe, our emissions are actually harming the trees. So, we don't actually know the real cost that urban trees face.
Yeah, that's really interesting. So, I love just I think this is the reason why I really love ecology so much, is just thinking about those connections between different components of the ecosystem. So, you have humans are having this effect on forest fragmentation, which in turn has an effect on how the trees are impacting our lives. And it's just it's so cool to think about, and it seems like this is a really important subject. It's so awesome that you get to study it. I'm like
Yes, I love it. I definitely I like the way right when we answer a question, it brings up a new one, right?
yeah, exactly. So you've talked about human health so far. You talk a little bit more about how you incorporate human health perspectives into your work.
Yeah, so I am part of the urban program at BU, and the urban program trains PhD students in multiple different disciplines to help us become experts in how humans affect our ecosystems and how our ecosystems affect humans. So, among many opportunities that the urban program provides, we get to incorporate a multidisciplinary approach to our dissertation research. In that way, I plan to look at how different forms of green spaces remove particle pollution from the air. So, going back and talking about particulate matter, um, if someone lives nearer to, say, an open grass field, will they be more or less exposed to particulate matter or particle pollution than someone who lives near a forest? So, I plan to start that research next year, since 2020 research has been put on hold, but no one has really got a good grasp on how much pollution a field removes versus how much pollution a forest removes, or maybe a small park with a couple trees. So I plan to actually put numbers to that and understand how human health is affected depending on where you live.
Cool. That's such an important question, right? Because as people and city practitioners are making decisions about what sorts of features that they want to implement and preserve in their city, it's so important to have those concrete numbers comparing the different types of ecological infrastructure features that exist and seeing which ones are best for or under different circumstances with different goals in mind.
Right. Yeah, we definitely need to take that into account in our urban planning.
So this podcast very broadly is about urban resilience in the face of climate change. So I was wondering, from your perspective, what are some major challenges for urban forestry in the face of climate change and climate change extremes?
Urban forestry is a widely used strategy to mitigate climate change effects, which we know this. We know how often urban forests are used to mitigate different effects, but we don't know how. We can't necessarily put a number on it, right? So, not only do trees take up pollution, and we're continuously quantifying how much they can actually take up, but they also combat the urban heat island effect, which refers to the heat that cities produce. So the urban heat island will continue to increase as the effects of climate change become more prominent. Um, Additionally, we see more flooding due to climate change. Trees can actually reduce runoff and control stormwater, which I know that you probably have a little bit of experience in. But tree roots are able to control some of that flooding. The issue is that we need to make sure we're planting the correct type of trees to mitigate the effects, or else they won't be able to handle the extremes. They won't be able to handle the heat. They won't be able to handle drought. A lot of urban trees already show stress due to heat and drought. Um, and then, of course, those consequences of climate change also affect human health.
Yeah, absolutely. Yeah, this is something that that I think a lot about in my research here in Phoenix and my tree related research. And something that we talk about here is whether or not, and that we sort of alluded to this earlier in our conversations, whether trees are really the appropriate strategy in the face of climate change, at least for us. So there's a lot of talk about building up more built shade structures. So you would get like the cooling effect from shade that you'd get from trees without the concern about how much water that they take up. But of course, a built shade structure doesn't provide a whole range of benefits that trees do.
Right.
Yeah,
Like habitats.
like habitat, right? And a shade structure wouldn't typically help mitigate stormwater issues either. uh,
Right, exactly.
wouldn't help improve air quality. It wouldn't do a whole bunch of other things. And just in general, I think trees are nicer to look at than built shade. Although there are some very
Oh, that's just my personal opinion.
and no bias at all. No bias at all.
Definitely.
Okay. Moving on to the last couple of questions. So, what's a misconception about urban trees that you would like to clear up?
Yeah, so there's definitely a lot, I think. The main one I hear in my field is that trees pollute the air more than they help mitigate pollution. That isn't necessarily true. There are definitely trees that emit pollution, especially in the form of pollen and VOCs, which are volatile organic compounds. Um, the VOCs are just gases that can contribute to ozone formation. There are trees that do that. However, different species emit pollutants at different rates and in different concentrations. So there are trees that are very low emitters, and we just need to make sure in the concept of urban planning that we plant low emitters, and that will not become an issue at all.
Yeah, I think that's a really important point that you're making, is just that we need to be very deliberate about the decisions we make about trees, because each different tree is going to provide a different suite of benefits and costs. So we need to find the trees that sort of maximize the benefits while minimizing the costs. So I think this sort of calls out to the importance of the sort of research that you're doing, looking at tree species differences so that people can make more informed decisions about what trees to plant, when and where, and for what purpose.
Right, exactly. Yep. It's all relative to the least harm for trees and the least harm for humans.
So now we've come to my favorite part of the show, which is where I ask people to share a haiku summarizing some aspect of their work. So were you able to come up with a haiku?
I was able to. I feel like it's terrible, but
That's what everybody
I'll read it if you
everybody
want.
says, but they're always great. I can't wait to hear it.
Oh gosh. Okay. So my haiku is: trees help cities breathe, but cities can hurt trees too. What is the real cost?
Excellent. Love it.
Oh god, I'm not a poet.
Oh, that's all right. That's all right. It's still fun.
It was fun to come up with that.
Excellent. Okay, well, that's pretty much all I had as far as tree related questions go. Thank you so much for joining us today. This was a really fun conversation. I know I learned a lot. Thanks so much for taking the time to be here.
Of course, thank you for having me.
The Future Cities podcast is an outreach effort brought to you by the Urban Resilience to Extremes Sustainability Research Network, or UREX as we usually refer to it. To learn more about UREX, visit www.sustainability.asu.edu/urban resilience. If you have any questions, feedback, or suggestions for future episodes, you can email us at futurecitiespodcast@gmail.com or find us on Twitter at FutureCitiesPod. If you enjoyed the episode, please rate and subscribe to us wherever you get your podcasts. See you next time.